Okay, so we are going to look at summations. So this thing right here is called a summation, and you will always have a letter or a variable. It doesn't have to be any, it can be any variable you want, and you pick a number that it's equal to. So let's just say it's 3. Then you pick another number that goes on top of it. So let's just say 5. So this is going to be the number you start with. This is going to be the number that you end with. So then out here you have some expression. So let's say we have 2, and then the variable that's in this is the same variable that you put down here. So let's say 2n plus 1. So this thing is called a summation. So that means we are going to sum, or we're going to add things together. So my first number is a 3. So I take 2 times 3 plus 1. Okay, we are adding. So my next number, so we're going from 3 all the way to 5. So my next number is 4. Then you take 2 times 4 plus 1. And then my last number is 5. So I take 2 times 5 plus 1. So this gives you 7, this gives you 9, and this gives you 11. And when you add those together, you get 27. Okay, so now this one was easier because there was just 3 numbers, but once you get into harder ones, so let's say, yikes, that was a terrible, there we go. Okay, so this time, let's just pick X, and let's say we start at 3, and we go to 15, and we have, let's do negative 2x plus 5. Okay, so we know my first number. I plug this 3 into here. So if I plug a 3 in, I have negative 2 times 3 plus 5. So negative 6 plus 5 is negative 1. Okay, so now we can use the formula that we learned in class. So is this arithmetic or geometric? Well, this is linear, so it's arithmetic, so we're adding every time. So that formula was you take your first number plus your last number times your number of terms and divided by 2. Okay, so we just figured out what my first number is negative 1. So we have negative 1 plus my last number. Well, my last number is going to be, I just plug 15 into here. So I have negative 2 times 15 plus 5. So negative 30 plus 5 is negative 25 times your number of numbers. So this is where a common mistake will happen. The common mistake is, so if you're going from 3 to 15, automatically people will think 12. But if you actually count them out, you have to count the number 3 and you have to count the number 15. So if you actually count them, okay, so let me show you with something smaller. So like, let's say you have the numbers 1 through 4. So you have the number 1, you have the number 2, you have the number 3, you have the number 4. Now why? Oh, 4. There's 4 numbers. But if you subtract these, 4 minus 1, you just get 3. So you have to make sure you count. So if you subtract, you can subtract, but you have to add an extra number into it. So the number between 3 and 15, there's actually 13 numbers. So if you actually want to count those out, go ahead. So there's 13. And then you divide by 2. Grab my calculator. So we have negative 1 plus negative 25 times 13 and then divide by 2. So the answer is negative 169. So that was with an arithmetic one. So again, the biggest mistake that kids will make, they subtract these. If you subtract these, you get 12, but you have to include both 3 and 15, which makes your number of numbers 13. Okay, so let's try one with multiplication. So we can do r equals, let's do 0, and then let's go to 11, and let's do 4 to the n plus, or to the r, excuse me, to the r plus 1. Okay, so this one, our first term, we plug in a 0. So 0 plus 1 gives you 1. 4 to the first is 4. So once you see you have a variable in your exponent, you know it's going to be geometric because you're multiplying 4 times 4 times 4 times 4. So our formula for geometric was a times r to the n minus 1 over r minus 1. A is your first term, r is what you are multiplying by, or your multiplier, and n is your number of numbers. So let's see here, we plug in 4, that's our first number. R is what you're multiplying by, so we are multiplying by 4 every time, which is this number. And then to the power of n, so number of numbers. So we have the numbers 0 through 11. So if you were to start at 0 and go to 11. So remember, if you're subtracting, you only get 11, but there's technically 12 numbers here. You have the numbers 1 through 11, which is 11, and then you also have to count 0, which is 12. And then minus 1 over r, which is 4, minus 1. And if you type that into your calculator, you get 4 to the power of 12. You get a giant number of 22,369,620. Okay, we'll do one more. So if we have, okay, let's say we have x equals, let's do 3, and we'll put a 10 up here. Let's say we have 1/2 to the power of r. Okay, so this time, so we have this, we have a variable in our exponent. So that means you're going to be multiplying, which means it's geometric. So we're going to use a times r to the n minus 1 over r minus 1. A is our first number. So if I plug a 3 in here, that gives you, let's see here, that'd be 1/8. 1/2 to the power of 3 is 1/8. Then in parentheses, okay, that's right. We have r to the n. So r is what you're multiplying by, which is 1/2. N is your number of numbers. So you subtract these, you get 7, but you have to add 1, so that's 8. Power of 8, and then minus 1 over r, which is what you're multiplying by, minus 1. I'll go ahead and put that in my calculator. And I got approximately 0.25.